let us solidify our understanding of what logs are by doing some more practice. So last time we had practiced with the first question, what is log of 10,000? And remembering that log of x to the base 10 equals a means that when 10 is raised to the power of a, you get x, or the value of log of x to the base 10 is the number by which you must raise 10 so that you get back x. Remembering that definition, we ask, what is the power to which we must raise 10 so that we get 10,000? Well, we should raise 10 by the power of 4 in order to get 10,000. So log of 10,000 to base 10 is equal to 4. And also remember that if the base is not specified, you assume that the base is 10. So with that in mind, let's look at the next problem. So log of 0.001, what is that? Well, first of all, the base here has to be assumed to be 10. So the question really is, what is log of 0.001 to the base 10? Now, 0.001 is equal to 1 divided by 1,000, and 1 divided by 1,000 is 1 over 10 to the power of 3, which is 10 to the power of negative 3. So this 0.001 can be written as 10 to the power of negative 3. And you can clearly see that you need to raise 10 by the power of negative 3 in order to get 0.001. So the log of 0.001 is equal to negative 3. Next one, what is log of 10? Well, what is the power by which we should raise 10 in order to get 10? Well, 10 to the power of 1 is equal to 10. So log of 10 to base 10 is simply equal to 1. Well, what is log of 1? Again, we ask, what is the power by which 10 must be raised so that we get 1? Now remember, anything raised to the power of a 0 gives you a 1. So 10 raised to the power of a 0 will give you 1. So log of 1 to base 10 is equal to 0. Now this last one, it's an interesting one. What is log of 1 to 1 over 4th power of 10? So remember that the denominator here, 4th power of 10, can be written as 10 to the power of 1 over 4. And since the power is in the denominator, the entire expression 1 over 10 to the power of 1 over 4 can be written as 10 to the power of negative 1 over 4. And as soon as you realize that 1 over 4th power of 10 can be written as 10 to the power of negative 1 over 4, we can immediately answer the question, what is the power by which 10 must be raised in order for us to get 10 to the power of negative 1 over 4? Well, it should be raised to negative 1 over 4. So log of 1 over 4th power of 10 is equal to negative 1 over 4. So I hope with that we clearly see that logs defined in the following fashion, where log of x to the base 10 equals a means that 10 raised to the power of a is equal to x. We can clearly see that log of x to the base 10 is the inverse function of the function 10 to the x. And we've seen that in a couple of ways. We've seen that in tabular form. We've seen that when we write the functions as logic machines, and we've seen that when we use our normal steps for inverting f of x equals 10 to the x. And the final thing I want to point out is we also know that the inverse function of some function is the reflection of that function in the y equals x line. So what I've done here is I've got y equals x line drawn right here. This is where the mirror is. This is where we're going to take the mirror is what we're going to take the reflection in. So y equals x line is where the mirror is sitting. And then I plotted the f of x equals 10 to the x function. And now as we stare at this, we can see that the inverse function, which is going to be the reflection in y equals x line, is going to look like this. And the inverse function, which is the image of 10 to the x and y equals x, is going to be the graph of log of x to the base 10. Okay, so that's all I have to say about the definition of logs.